Okay, continuing on from where we left off. Again, the question was asking two questions in one, really. The volume when you rotated this region around the y-axis, let's do that one first. Okay, we've got x squared plus 1. Oh, this is one branch of it. X equals 0, which is the y-axis. X equals 1. And y equals 0, which is the x-axis. So this region that we have in the first quadrant in part A is going to be rotated around the x-axis. So let's pick a shell. In this case, as always, let's pick a representative rectangle. The geometry of the situation dictates what kind of a rectangle we can select. I have to select a rectangle like this. Why? Because this rectangle will have the same neighbors throughout the region, right? If I went with the other kind of rectangle, on the bottom it has different neighbors, on the top it has different neighbors. You can actually do the problem like that also, but you have to split it up where the neighbors change. You have to set two separate integrals. It becomes messy. I wouldn't recommend it. Okay? If you want to do it with a single integral, we need to pick your rectangle like this. The thickness is delta x, right? Since the rotation is around the x-axis, and since this is parallel to that axis, what method do we have to use? The shell method, right? Since the representative rectangle is parallel to the axis of rotation, choose the shell method, which says volume equals 2 pi times the integral of shell radius. What would it be in this case? This would be your shell radius, which is x. Can I keep it as x? Yes, because I'm going to put my delta value, the dx, that tells me everything can be in terms of x or should be in terms of x. So shell radius is x. How about shell height? Shell height? Normally it's y, but since y equals x squared plus 1, I'm going to use that version of it, the version in terms of x. And the limits of integration? 0 to 1, correct? Multiply the x's, plug the values in. What did you all get? Because I know everybody will be able to do this question. The details of it. What was your final answer? 3 over 2 pi or 3 pi over 2, right? Everybody got that? Okay. Let's also take a look at how do we set it up for the second part. Same region, really. The only difference is you're rotating it now around the x-axis. By the way, if you look at what the region looks like, if it goes around the y-axis, it looks something like this. There's no hole in the region, right? It's like a cylinder where like a hemisphere has been carved out of it in a sense, right? Okay, now what will the second one look like? Same starting region, but now we're going to rotate it around the x-axis. So the final figure will look much different. Final figure will be something like this. So contrast this with the figure above. So we don't expect to get the same answer because the region, the volume, or the solid that we're getting is really not the same solid. So you wouldn't expect to get the same answer for this question. Okay, from our original region, I select a rectangle. I must select this rectangle. I'm stuck with it because of the geometry of the region. If I want to have the same neighbor on the top and on the bottom, that's what I have to do. And this was my original region. Let me just re-emphasize that. Okay. Okay. Rotations around the x-axis. Can I use the shell method? No. It's perpendicular to the axis of rotation, so we have to use the disk method, where the volume is pi times the integral. It's going to be big R squared minus little r squared. But is there going to be a hole in this region? Is there anything to subtract? No, so there is nothing to subtract. And big R, by the way, the thickness is delta x, so I might as well put that in here as dx. Once again, limits will come from the x-axis. And finally, I want big R squared to go in here. And the radius of your washer is going to be this distance. This is your big R. And what can I write for that in here? What is the big R here? X squared plus 1. And it has to be squared because the formula said pi times big R squared minus little r squared. This was 0, but then we put the big R squared in there for us. And once again, I know you can integrate this, distribute the binomial, integrate piece by piece. Did anybody find an answer for this? Very good. 28 pi over 15. Excellent. Again, how do we do that? Expand your binomial, integrate piece by piece, and then plug in the numbers. Okay. All right. I'm going to give you another example where you can work on the setup. Okay. Anybody else? Anybody needs this page further before I move on to another page? Okay. A similar question with two different functions. The answer for part B for the last question was 28 pi over 15. Good.
When am I supposed to use this to just washer versus shell?
Okay, I'm going to start by finding where these two functions intersect. So x squared is equal to 2x. So they intersect at the point 0 and 2. So the 0 is obvious. That means this point right here is going to be the point of 2. Okay. In part A, we want to go around the x-axis. Okay. For this question, either type of rectangle would have worked. So you really don't have to go with one rectangle or the other. You could really pick any kind of rectangle you want. Just be careful. For example, if I pick a rectangle like this, and I'm going around the x-axis, what method should I be using? This washer method, right? In this case, washer, because there's a hole in the region. Now, I've noticed a lot of you try to set it up with the shell method. So I will also come back and set up the same problem with the shell method, so you can check your answer that way also. Okay. So with the washer method, how would I set this up? The thickness is delta x, and according to the washer method, volume equals pi times integral of big R squared minus little r squared, in this case dx. And limits are 0 to 2 because they're coming from the x-axis. Okay, what is the outer radius here? That would be this distance, right? And the inner radius? That would be this distance. Okay, so the outer radius, which function is that on the outside of the region? Again, this is our big R. So that's the 2x function, right? So it has to be squared though, right? So quantity 2x squared minus the inner radius, which is this one. And that's the, which function was that one? The y equals to x squared. But that has to be squared as well. Again, this is the inner radius r. That's the squaring function. But the formula says square that one as well. In simplified form, we are looking at pi times integral 0 to 2 of 4x squared minus what? X to the 4th dx. And again, I trust you're going to be able to integrate this. And the answer that you found was 64 pi over 15, correct? 64 pi over 15. Okay, I'd like to also set up the same problem with the new method, the shell method. How would we set up the same problem with the shell method? Okay, so now you have to select a rectangle that is parallel to the axis of rotation. So let's just do a very simple graph here. Our rectangle is going to look like this. Okay. Immediately, what is the thickness there? What is the thickness? Delta y or dy. What is the shell radius? Which is this distance. Shell radius is y. How about the shell length? What's the length of that rectangle? That was the tricky part. What is the length of that rectangle? Because that rectangle is bounded by two functions, the length of the rectangle will be right minus left. Okay, so what function is on the right? It's the curve, which is y equals x squared, but it has to be in terms of y. So if y equals x squared, x equals square root of y. Minus, so it is right minus left. Left is the line, y equals 2x, but solve for x. If y equals 2x, x equals y over 2. And how about the limits of integration? 0 to 2 were the x limits. What will the y limits be? 0 to 4. If you solve this integral, multiply the y in, integrate piece by piece, you should get the same final answer. Okay? So this should, when you finish this one, you should still get 64 pi over 15. It should be the same answer because we did the same problem. It's still rotating it around the same axis. We just use a different method. It should be the same answer. Now, let's do the same problem, but part B of the problem, which is the rotation is around the y-axis this time. The rotation around the y-axis. So we got y equals x squared, y equals 2x, but we're going to go around the y-axis. Once again, we have a choice. We can really pick any kind of rectangle we like. I'm going to begin with the one I think is going to be easier, which is the shell method. I'm going to pick a rectangle like this, one that is parallel to the axis of rotation. The thickness there is delta x, right? So since I'm going with the shell method, I know the constant should be 2 pi. The limits will come from the x-axis. Was it a 2? I think so. I can immediately put down my dx, so I don't forget that everything will be in terms of x. With the shell method, you want two variables in there. Number one, the shell radius. What is the shell radius here? X. And then you're going to need shell height. That's a little bit tricky. We've got to be very careful. Shell radius is x. How about the shell height? What is, in other words, the length of that rectangle? That rectangle is bounded on the top by one function, bounded on the bottom by another. So what would be the length of that rectangle? Exactly, Kevin is right. Top function minus the bottom function to find the length of that, which will be exactly, Joshua, 2x minus x squared. Now, we could multiply the x, integrate term by term, and we should get, anybody who got something? Good. Who got that 8 pi over 3? Some of you got it? Okay. With that method. But I know some of you use the other approach, so let's try to set it up with the other approach as well. How many of you use the other approach for this problem? Okay, so I know you're going to want to see the solution that way also. Let's just set it up. So now we're going to, same problem, but I'm going to pick a different kind of rectangle. So we're still going to go around the y-axis. We still have the same two functions. But now I'm going to pick a rectangle this way. Okay, that will force me to use which method? Your rectangle is perpendicular to the axis of rotation, correct? So which method should we be using? Washer, because there's clearly going to be a hole in the region. You choose between disk and washer. In this case, it should be the washer method. Okay, with the washer method, and we know the thickness is delta y, I can set up a generic integral here, pi times Big R squared minus little r squared dy. Okay. So I need to know right now my big R squared, or big R to begin with. That's the outer radius. That would be, and just to show you, if I was to rotate this figure around, and this was my original rectangle, this becomes your washer basically, right? So what is the outer radius of this washer? It is this distance from here to the end of it. This is your bigger radius, right? So what is that? And you've got to give me the answer in terms of y. That function is y equals x squared, but in terms of y, what would it be? X equals square root of y, but don't forget to square it. Minus the inner radius, that's this distance right here. Exactly, and don't forget to square that one as well. X equals y over 2. And how about the limits of integration? 0 to 4, remember, if x is to squaring function, y would be 4. So if you finish this integral, either one turned out to be just as bad. One is not that much easier than the other. You should get the same final answer, which is 8 pi over 3. Okay. I'm going to give you one more to set up. By the way, as part of your homework, can you please do this? Please add this to your group activity problem for the last, actually either section, this section or last section. Remember last time I did the volume of a sphere using the disk method? I want you to do the volume of a sphere using the shell method. And the way you're going to do it, just like we did last time, you're going to start with, let me make this a little bit larger. You're going to start with a quarter of a circle. Last time we rotated that circle around the x-axis. Now I want you to rotate that circle around the y-axis. Okay. Okay, and finally, I'm going to put in one more example on the board. This one I would like for you to complete in your groups. You don't have to solve the entire integral. All I'm going to ask you is, can you set it up? Just set it up and agree with your group members before you leave today, okay? And the question is, okay, actually, I think I have a picture for that. See if I can pull it up. Around the y-axis for the last problem. There it is. Okay. So we have a region that is bounded by the line y equals x. The curve y equals square root of 4 minus x squared. In part A, I want you just to set up an integral. Assume the rotation is around the y-axis. Right. Rotate around y. Just set it up. And in part B, rotate around the x-axis. Just set it up. At home, I want you to finish it and come back with answers. We'll check your answers next time, okay? Again, just setting it up in class. Okay, so everybody had some time to think about this. Now let's put the solution. First, the rotation is around the y-axis. So I can take the given region. First of all, I need to select my representative rectangle. And in this question, I really don't have a choice. My rectangle has to be in this direction with a thickness delta x. The reason being, this rectangle has the same neighbors throughout the region. If you try one of the other kind, a horizontal rectangle, you will see that that won't be possible. So we have to pick this rectangle. With that selection, and since the rotation is around the y-axis, we are forced to choose a single method. Since our rectangle is parallel to the axis of rotation, we're going to use the shell method. So here's how we set it up. 2 pi times integral of shell radius. Shell radius will be x. Shell height. The height of our rectangle, since the rectangle is being bordered by two functions, the height will be the top one, which is root 4 minus x squared, minus the bottom one, which is x. The thickness is the x, and the limits will come from the x-axis. But what are they? To answer that question, let's go ahead and set the two functions equal. Square both sides. So we get 2x squared minus 4 is 0. In other words, x squared is equal to 2 if you divide both sides by 2. And then put the negative 2 on the other side. X squared is 2. X is plus or minus root 2. On the first quadrant, it can only be positive root 2. That means the point of intersection over the x values is the square root of 2. So we're going to be going from 0 to the square root of 2. Again, I only asked you to set this up, but let's think for a moment. How would one go about integrating this? So volume equals 2 pi times the integral of, I'm going to distribute the x. Same limits, 0 to root 2. To integrate the first part, guess which technique we're going to need? Use substitution, right? And the second part, the integral, is very simple. The integral of x squared is just negative x cubed over 3. To integrate this portion, let u be equal to 4 minus x squared, so du equals negative 2x dx. And our integral becomes the integral of, all right, x dx will be replaced by negative du over 2. And I also have a square root of u in there. So basically, I should be integrating square root of u du. The other part, I've already integrated it, so I don't have to worry about that. And if I simplify further, 2 pi times quantity negative 1 over 2 times u to the 3 halves over 3 halves, or times 2/3. And let's put the u back in there. U being 4 minus x squared. Okay, Okay, we're going to go from 0 to the square root of 2. Starting with the upper limit of root 2, we plug that in. We're going to have negative a third 4 minus root 2 squared, which is 2. So 4 minus 2 is 2 as well. 2 to the 3 halves minus root 2 to the third is also 2 to the 3 halves. Now plug in the lower limit. When you plug that into the first part, into over here, we will have minus, another negative will give me a plus 1/3 times 4 to the 3 halves, because 4 minus 0 is 4. And minus 0 cubed over 3 is still 0. Let's see, if we simplify this a little bit further, two to the 3 halves is the same as 2 root 2. And I have 2 of those up there. Plus 4 to the 3 halves. Square root of 4 is 2, 2 to the third is 8, so that's 8/3. So if I simplify everything, I will have, and I put the positive term first, 8 minus 4 radical 2 over 3. Okay, that's our answer for that part of the question. And again, we had to use the shell method because of the way we selected our rectangle. Okay, let me do the rotation around the x-axis elsewhere. Actually, that would be a lot easier, so I might as well try to squeeze it right in there. Okay, this time, once again, we have no choice but select our rectangle this way with a thickness delta x. But now we're going around the x-axis, so we're going to be using the washer method. With the washer method, volume equals pi times big R squared minus little r squared. Everything has to be in terms of x. Our big R is going to be this distance, and that is the square root function, which will have to be squared. Our inner radius is this distance, which is the line. Again, it has to be squared. And the limits come from the x-axis. So when we square the radical, we lose the square root sign. And all we have to integrate now is the integral of 4 minus 2x squared from 0 to 2. And that's the same as 4x minus 2/3 x cubed. Excuse me, my limits were square root of 2, and I've been carrying it wrong the whole time. So let me fix that if I could. All right, 4x minus 2/3 x cubed, and once again, going from 0 to square root of 2. So that'll be 4 times radical 2 minus 2 times, it's going to be 2 to the 3 halves, which is the same as 2 root 2. So root 2 to the third is the same as 2 radical 2. And minus 0 gives us nothing. So here I have 4 radical 2 minus 4 radical 2 over 3. So it's going to be 2 times 4 radical 2 over 3. Again, you can simplify it a number of ways, but your final answer should be h root 2 times pi over 3. That's if the rotation is around the x-axis.